Well, welcome everybody. I'm gonna be that rude American that I am, and I want to make sure that you actually can get something out of this. And you have to see these two very clearly with your actual eyes. So these two rows are empty. So everybody, all need to stand up and try to pack in these rows as much as possible, because otherwise you're not really going to get much out of it. So I want to make sure this one, you don't want to be in these front rows here because you're going to get blocked by this. So it's this row here, and you can fill these up as much as possible. If you can do that, I appreciate it. So, but it'll be more for you, not so much more for me. So thank you so much. Okay, because if you're here, then you can't see the screen. That's why I figured it out. Yeah. Okay. All right. So I have your attention now, and I wanted to start with the whole point of this, so that if you're just walking in now, or if you handheld? Oh, there it is. Okay. So if you want to get one thing out of this phrase, just remember, if you ground your vision, then you can trust your eyes. Okay, that's the whole point of all this. We will unpack this phrase. We will go through all the kind of ideas behind this. But just remember, if you want to ground your vision, you have to trust, then you can trust your eyes. Okay? Now, we're going to turn off the lights now in the room, and we're going to look at the front here. So what I'm going to do is flip this to red, okay? And actually, instead of flipping to red, I've got a camera here, okay? And, oh, did the camera shut off? Is it still on? Okay, great, cool, great. All right, and what I'm going to do is I'm going to go live with these lights. Hit go, okay? So you can see that this is a live feed of everything. Well, there's my hand. Ooh, yes. What color is this? Red. Good. What color is this? White. Okay. Now, what I'm going to do is I'm going to turn off the white lights. You kind of get used to it for a little bit. Or you can close your eyes for a moment, open it up again. Some people I've noticed, I've been doing this lecture now for about 2 years, on and off around the world. Does this still look red, exactly red to you? See, someone said that. I saw some head going, maybe. It kind of turned a little orangish, right? But if you notice on the camera, it's still pure red. Okay, so I'll go back and forth. We'll go back to this. With the white light, very clearly red. And I go here. Kind of a little settle a little bit. It doesn't look so clean red anymore. It's not that pure red anymore. Okay. Will this ever impact you in real life? But will this impact you on a film set? Absolutely. So we can come up with the lights now. So that's the whole point of this lecture is I want to make sure that you can start trusting your eyes on set. Because if you do not have a white reference or something to ground your vision, your eyes start playing tricks on you. Things start to change. You make decisions. The camera doesn't see those decisions. Then you got problems. And that's the whole lecture. Thank you. I'll see you tomorrow. Okay. All right. But just if you don't know who I am, I'll just introduce myself really briefly. I'm a very proud father and husband. I am a cinematographer. I devoted my life to cinematography. It's my calling. I went to film school. I shot movies, documentaries, YouTube videos, even more YouTube videos, and even more YouTube videos at the start of my career. And now, apparently, YouTube is the highest form of content that people watch now, apparently. But I also was very lucky to become part of the ASC organization as an associate member. This shirt shows I'm also a member of the local union for lighting in the United States. But also very proud to be part of Imago as an associate member of of Imago as the ITC, the Imago Technology Council. So, and I'm also the principal engineer of imaging applications, which basically I just tell Aperture's engineering team and marketing teams and sales teams what they should do or understand about light, about customers, about what we do as cinematographers. So that's who I am. And I just want to thank all the organizations here. This camera's from Sony, so thank you for Sony. And most importantly, all this stuff up here is here due to the help of Christoph right here. So thank you, Christoph, who's Iron Hand Film in lighting in London. So if you're in London, you want to shoot in London, you need a gaffer, this guy right here. So what is this class? This is a technical deep dive into physical perception concept. That as you do filmmaking, and for people that do filmmaking, you really need to understand these concepts of your brain. Otherwise, you're going to get yourself in trouble that will cost you money and embarrass you. So, why do I say this? It happened to me. And I'm just here to try to give you a guide into how you can prevent this from happening for yourself. So that's the whole point of this. Now, this is not a class on color theory. This is not a class on giving you an idea about how to be an artist in terms of what color and color, matching and all that. That's a color class. That's a artistry class. This is a class for technical reasons to help you with your politics on film sets. Okay, so that's the distinction here. So the structure of the talk is we're going to explore this in 3 dimensions. Why should you ground your vision? Well, your eyes will lie to you in 3 different ways. They lie to you because they adapt constantly, as you saw. They lie to you because your eyes cannot see physics, okay? And finally, your eyes will lie to you because they don't always agree with your camera, and your camera is what matters for your final product. So that's how we're going to explore this in three different dimensions. So, and I guess we could go back up on the light now, because if I leave this off, you're going to fall asleep. So, all right. So now, in order to explore all this, I want to explain the context here. So first of all, we're doing a camera test. We've got a Sony camera. It's an FX3. It's set to output Asscociate 3.cine. That's the color space, if you're familiar with color spaces and workflows. It's literally just putting out its native calibrated signal set to 3200 Kelvin, right? So I'm just unprocessed feed, but it's not shifting, it's not changing. Its exposure is constant, white balance is constant. I'm feeding it into this program called it's low on batteries? Yep, it's low on battery, that's why. Yeah. So maybe we should we pause? Yes. Yes. Yeah. I was like, it happens once or twice, but if it happens 3 times, that's a problem. So we'll just do this. Yeah. Checked. Oh, there you go. Okay, so this is fine too. Okay, so where was I? So this camera, right? I'll show you the actual camera feed. This is the actual camera feed right here, and the color space again that's the input color space, and all I'm doing is just converting it to the working color space of the program, and it's just outputting basically sRGB, because this projector is a standard sRGB color space projector. So I'm not doing any LUT. I'm not doing any particular quote-unquote look. This is purely an engineering conversion of what the camera's calibrated to do and just giving you the exact values as much as it can. So what we just saw up there, what we're seeing right now, we're just trying to trace the values and just be as honest to what the technology that we have is doing. So we're all on the same page. I'm not doing any tricks, not doing any LUTs, not doing anything. It is exactly what the system is without any creative control, because this is our basis for everything we do after the fact. Okay, so that's our context. So, so now, what I want to test is, now I know what my setup is, I always test either faces, fabrics. So I always make sure we have all the faces and stuff in here when I do a camera test to understand what I'm doing. And I have also fabrics and paints right here. So as you can see here, I've got grade charts, and I've got color charts and fabrics, and then flowers and fruits and vegetables. You just want to make sure that you are seeing a light on things that you know, so that you can actually evaluate what's happening. So that's the whole point of all this. So that's what we're trying to understand here. So now, with that context, I've just stripped it down to just understanding adaptation of what the light does to camera. So that's all we're going to do today. So we have we have an aperture 80C right there. That's this light right here. This is a 600C bouncing off of here. And then we've got a tiny little infinibar right there. Okay. So how do eyes lie with adaptation? Okay, so can we turn off the lights again briefly for this? So what we're going to do is another color experiment. Okay. And I'm going to do a really difficult test here again. What's that color on the left? Red. It's really, it's supposed to be red. That's Rec 709 red. Okay. But you just heard an answer from the world's foremost authority behind color science for video, and literally the guy that defined what 1080p actually is. So you have to understand that you have an actual expert here. Yeah, exactly. What's the middle color? Green. And what's the color on the right? Blue. Okay, so now what I'm going to do is I'm going to kind of squeeze it down, okay? And then I'm going to squeeze it down again to almost just exactly the limit of what your eyes can pick up. And I'm going to make a whole pattern of them, right? And I have a square on the left. What color is that square right now? White, okay? And what I'm going to do is I'm going to move that square to the right side of the screen and only cover the blue lines and have the green and red lines appear in front, right? So I'm going to do this, and here we go. It's moving around. What color do you see? What color is the box now? Yellow. But you know, sorry, I didn't mean to shout into the microphone. You know that it's a white box. You literally, I mean, all we did was just move it, right? I'll do it again. It's moving, right? It's still a white box, but we still think it's yellow, right? And just to prove a point, it's not a yellow box. What's going on? Again, anyone who's had any experience with color theory, additive color theory, what color do you get when you mix red and green? Brown? What if it's brighter than brown? Yellow, right? Brown is dark orange or yellowish, depending on your perspective. But yes. So yeah, green plus red gives you yellow, right? And what's going on here is I'm going to magnify this, okay? Right? I'm going to magnify it. And what's going on here is that you're bordering the white with two other colors that are saturated, and your eyes start blending it together. And so instead of seeing the white, you start seeing the more dominant saturated colors. Your brain confuses it and mixes it, and makes it yellow, okay? This is the first point of your eyes are constantly, never stopping, adjusting all the time of what you see. And on the first dimension of it, what you just saw up here, and what we also saw with this example right here, is, and let me go back here, is that we adapt according to space. Physical objects in space, your brain is always calculating based off the context in space, right? And now what we're going to do is do this in terms of time. So we did this demo already. We can do this one. So what I want to do is read the words time adaptation 10 times in your head. You don't have to read out loud. If you want to read out loud, you can, but time adaptation, adaptation. So I'm going to flip the color. What color do you see on screen? Cyan. Some people say. Now you see gray. No, but it took you a while, right? Most people, when you flip it right away, they don't see gray. It took a while. Your eyes have to adjust over time, right? Again, so we stare at this for a moment, 10 seconds even. We get used to the red, and when you flip it, you see blue, right? Especially in context of the letters in the middle, because the letters actually don't change. It's actually exact same color in the middle. So this is called time adaptation. So we have two dimensions of the way that our brains are constantly adjusting all the time. And I've experienced this on set where I shot a lot of documentary, and I go to a location, and I see the sun coming in, and I'm used to the sun, and when someone struck an HMI, just so show my age, I used HMIs. And this is about 10 years ago, and I just vividly remember this. It looked very magenta, extremely magenta. And I was like, what happened to this light? But when I metered it, it was clean. It was actually clean. But it's because my brain got so used to the light of the sun going through a greenish window. And when I turn on that HMI, that's balanced perfectly, quote unquote, because it was it was much more balanced. It looks magenta, and I immediately was going to ask for the light, the gaffer, to get some green gel to correct it. So it took time, but then after about 5 minutes, it was okay, right? But because I had the meter, then you can tell that, oh, wait a second, it was just my brain. So this how do you fight this? That the answer is use a visual ground, okay? So what I mean by a visual ground, so in electricity, if you don't want to shock yourself, a safety thing is that if you have a ground, when you literally have a spike that goes into the ground that draws electricity, so that if there's a short or whatever, the electricity goes into the ground instead of you, right? Similarly here, you've got a gray bar on set that is set to the actual camera. So in this case, here's how you make a visual ground. I have a light right here, okay? And I'm going to turn it on in a moment. And with this visual ground, you set your camera the way you were setting it, right? Who uses auto exposure and auto white balance when they're on set? Thank God. Okay, good. All right, good. I was just waiting to see who's going to, all right, right? Obviously, you don't, because you need control, because if you set auto, you're in a world of pain in post-production, right? But because it is not constantly adapting, right, you have a ground truth, in which case this camera is set to 3200 Kelvin with a fixed exposure. And with that as your reference, now I can dial in this light to be perfectly neutral. And that becomes my reference. So this is not for inside camera while I'm shooting. This is for next to your actual monitor on set. And this is where the politics comes in. Because I've experienced working on commercials or other projects where the producers, the clients, they look on the monitor and they say, that doesn't look right. Has anyone ever experienced that before? Yes. Yes, you definitely experienced it. Yeah. It's very painful to deal with all these voices all of a sudden saying something doesn't look right. So what this does at least is it gets everybody's actual eyes looking at the right thing as white. Not daylight, not tungsten, not whatever. It's whatever the actual camera needs to see is white, that's white. So let's try this, okay? So I've got the setup here. As you can see, nothing is on, and I'm just gonna go right here, and I'm gonna go to just turn it on, okay? And it's kind of clipped out. Oh, sorry, I forgot. Okay, here we go. You can see that okay now, right? So that's this bar right here. And as you can tell, this is set to 5600 Kelvin. So what I'm gonna do is I'm gonna meter this right here. I've got this light meter on. It timed out. Wonderful. At least it's not gonna ask me to calibrate because it always. All right, so it is reading this light at, this is like watching paint dry. This is the best lecture ever. 6400 Kelvin, which looks very blue because I've set the camera to 3200 Kelvin. So what I can just do is, first of all, I have set it to RGB. Literally what I could do is, well, it's got too much blue. I can just look at the waveform monitor. Now, who here knows what a waveform monitor is? Do you know what a waveform monitor is? Raise your hand up high. Be proud. You know how to use a waveform monitor. Because no one ever wants to be the one that doesn't know how something is used. So as process of elimination, I know who doesn't. But it's not embarrassing to you. So now, right now it's cyan, because all I did was reduce the amount of blue. And I'll go even further. And I'm going to just dial that in. Sorry again. So I'm just using a program that controls lighting controls. So I'm now balancing out the blue and the green. Now it's a little too saturated, so here we go. That's pretty balanced. So the vector scope is in the middle. You've got R, G, and B equal amounts on the waveform because it's this thing here. And when I look at my eye, now I've got something actually on set that I can stare at so that I always know that red is red, green is green, blue is blue, whatever, right? And it's a tiny portable light that helps the most. Now, I used to do this maybe 10 years ago. I had to actually do this with a gray card and a tiny little light. And I would do that once in a while. You don't have to do it in every shoot, but when you know that you have to start making color critical decisions, or if you're on a set with a lot of color, or one single color, like a red color or blue or whatever, this becomes critical because otherwise you get lost, right? So having this, now with LED technology, you can get any light that you can color control, and within camera, you have to use your camera set to the right settings and dial it neutral, right? And now you've got your basis, okay? So we can go back up live again with the lights for a moment. Yes. It is 3200 Kelvin. And, sorry. Yeah. You do it with, well, that's why I have it with a light instead of a gray card, because a light is bright enough that most monitors don't split out. So, oh, yes. No, well, that's the whole point. Yeah, well, that's the whole point is that, especially because people are looking at a daylight balance, all monitors are daylight balanced to 6500 Kelvin. Every monitor, that's the standard. Yeah, when you got white, right? White is daylight balanced on a monitor, and that's another reason why. Let's say if it's a 3200 Kelvin show, if you're shooting with 3200 Kelvin balanced on your camera, this is even more important to have something like this to make sure that your eyes are based off of what the camera's seeing. So, yeah. So that's what I just learned over time as a cinematographer. When color really mattered, you just gotta have something like this on set. Otherwise, you just start drifting and making bad decisions, and that's when things get expensive. Or more importantly, politics. People start questioning you because they start seeing things their way and they don't understand why, blah, blah, blah. But when you get something like this set up in your monitor, no one ever questions it. They just see a light there. And their eyes just adapt to the brightest thing that's on set. Well, this is brighter than the monitor. And you don't have to have it all the time, but when it matters, you can turn it on, right? So that's the idea. Is you just need to have a reference. That's called a visual ground. Now, the final point is observers. Here's another little wonkiness, is you can't trust your eyes. You have to trust the camera because that's the arbiter of truth. So what I'm going to do is I'm going to do green screen, okay? Now, this light right here can do green screen, so I'm going to clear this. Confirm here. I'm going to hit go on this. So before we talk about the color of this, can we all agree that the camera sees this as green? You've got the vector scope is pointed to green. You've got green with equal amount of maybe a little bit of red and green, that is red and blue desaturating it. But if you even look at the CIE chart, which is actually correct, it's mapping the green all the way near Rec 2020 green. So this is green. But now, oh, sorry. Look at it with your eyes. Who thinks this is saturated green? Yeah. That's why I have this. Yes. So you got, but even, you have to also, this is my next talk at 4 o'clock, which we'll get into which is actually the whole point in my second talk. But you have to base your decisions ultimately by whatever produces the product. If this is producing your product, oh, sorry. It was a reflection was going on with me, sorry. If that's producing your product, if that's the basis of your product, your camera on set is basis of your product, you have to use that as the basis of truth, which is why we have this visual ground here on set to the camera, right? Because I can't trust this with my eye. I look at this looks lime. This looks kind of yellowish. But the camera sees it. And this is going to be the more extreme thing, because this has happened to me on set which is I wanted a new blue screen. Well, this is blue screen. The camera sees this properly exposed as blue. The screen sees it as pure blue. But what color is that? I would say violet, more magenta, but it's still not blue. Yeah, right? So once again, who do I trust? Do I trust my eyes? No, because I need to do keying in post. I want to have pure blue in post. So you need to have your camera be your basis. All right. So once again, the camera is your arbiter. So I'm going to go back here now, and we can go back up with the lights. It's just, again, I don't want people to fall asleep. Yes. Yes. But just so you know that that mapping you see on there is the S gamut mapping on the CIE chart. So it's still seeing it as blue. Yes. Well, let me see here. If I go here and I go monitor to my source, now the vector scope and everything is reading the source, which is the camera coming in. So that's you saw the change. It was very subtle. If I go back to UI, you did see that little change of where this little guy moves, but it's not a huge difference. It's still going to be reporting it as pure blue. If I even go here, oh, actually, maybe that's better. Yeah. Yeah. And actually, now that I'm looking at the S gamut signal, the S gamut signal still sees this as slightly cyan because I see more green than I do see red. Yeah. Yeah. But then it's not misleading because again, I actually need to go more violet. Yeah. So I could even do that if I yeah. So if I go there. Well, this is the most saturated. So if I do this, you know what I mean? I'm still getting. All I'm trying to do is equalize the green and red. Do you see what I'm saying? See, if I do that, it starts getting unbalanced. So the best you could do is to equalize that, and that becomes quote unquote the most blue you can get of this wide gamut signal. But even on the CIE chart, you can see that it's still directly lined up with the blue, the blue point, right? The gradient, all the gradient tones. So, but look at this. Whatever engineering thing we've done, we were talking about some engineering things, but it is purely lined up with the blue hue vector for S gamut, what the camera's just purely reading. This is what I need to deliver to this FX3 set to 3200 Kelvin to get pure blue. I need this to be my blue screen, right? And this is not a Sony problem. I experienced this with many cameras. I've experienced this with Alexas. I've experienced it with, I think Blackmagic. I tested 16 cameras to develop this lecture. So I'm losing track of which camera did what, but suffice to say, no camera is the same. That's why you have to understand that you have to, ground your eyes on set, because your eyes will lie to you, and you have to understand that the camera is the actual arbiter of what the color needs to be. So now, oh, sorry, I did the wrong thing. So there's these technical things I was going to get into. I was like, you know what? Do we really need to talk about this? Long story short, is basically what I said. There's so many combinations out there, so many cameras, so many white balance settings. you can see a huge array of values you need to plug in just to get the right value in the camera to do what you want to do. You just have to prioritize that observer, not you, that observer, to get the image results that you want. So the way that you do that, if you want to ground your vision and trust your eyes, use a visual ground to anchor your adaptation. And understand, he mentioned over there, that light is actually defined by its physics, which I didn't get into in this lecture. I will in my lecture at 4 o'clock. But also, you have to trust the camera, not your eyes, right, ultimately. This is a political thing. This is a political thing. This is a workflow thing. This is going to save your, I was going to say some other words, save your butts on set many times just for political reasons. But politics is everything on a film set. So it's great to have a light that you've calibrated according to what the camera is set to be quote unquote white or gray, okay? Neutral, R equals G equals B, right? And that's it. So in terms of my lecture, so we have questions. So we can go back up.